Determine all values of c that satisfy the conclusion of the mean value theorem for the function f of x equals 2x cubed plus x squared minus 6x on the interval -2 included to 2 included. The first thing to do is to determine whether the two conditions are met for the mean value theorem to apply. The first condition, the function f of x, which is 2x cubed plus x squared minus 6x, has to be continuous on the closed interval. 2x cubed plus x squared minus 6x is a polynomial. And a polynomial is continuous on any interval, so it is continuous on the interval of -2 to 2, closed, which means that it includes both ends, indicated by a square bracket on both ends. Condition 1 is met. The second condition, the derivative f prime of x, which will be first term power roll, bring down 3, multiply it with the 2, subtract 1 from the power, plus second term's power roll, bring down the power, multiply with the 1, subtract 1 from the power. Third term's a constant times x, derivative will be the constant. This has to be continuous. It's called differentiable on the open interval. Well, 6x squared plus 2x minus 6 is also a polynomial, and a polynomial is continuous on any interval, so this will be continuous. It's called differentiable for the continuity of the derivative on any interval, including the open interval of -2 to 2. It's always on the open interval, indicated by round brackets on each end, because the endpoints of a function are never differentiable. So it will be differentiable always on the open interval. It does not include either end. So condition 2 is also met. Since both conditions are met, the conclusion applies, and the conclusion is the slope of the tangent line at some value c will equal the slope of the secant line connecting the two endpoints, f of b minus f of a over b minus a. And this will be true for at least one c, perhaps more, in the open interval. In this problem, we have the interval of -2 to 2. A is the left endpoint, -2. B is the right endpoint, 2. So this right side will be f of 2 minus f of -2 divided by 2 minus a -2. The left side, f prime of c, can be evaluated by plugging c into f prime of x. That will give 6c squared plus 2c minus 6 equals 2. On the right side, we have f of 2 minus f of -2, which each can be evaluated with the f of x. F of 2 will be 2 times 2 cubed plus 2 squared minus 6 times 2 minus f of -2, which is 2 times -2 cubed plus -2 squared minus 6 times -2, all over 2 minus a -2, which is the same thing as 2 plus 2. So this equals 2 times 2 cubed is an 8, plus 2 squared is a 4, minus 6 times 2 is a minus 12, and then minus 2 times a -2 cubed, which will be a -8, plus a -2 squared, which would be a positive 4, and then a minus 6 times a minus 2 is a positive 12, all divided by 2 plus 2, which is a 4. So 6c squared plus 2c minus 6 will equal to 2 times 8 is a 16, plus a 4 minus a 12, and then minus 2 times a negative 8 is a negative 16, plus a 4, plus a 12, all divided by 4. 16 plus 4 is a 20, minus 12 is an 8, and then minus negative 16 plus 4 is a negative 12 plus 12 is a 0, so minus a 0 over 4. Well, 8 minus 0 is an 8 divided by that 4, which comes out to a 2. So we have 6c squared plus 2c minus 6 equals to 2. Since we have a trinomial quadratic, let's equate it to 0 by subtracting 2 from both sides. So 6c squared plus 2c minus 8 equals 0. Let's start by factoring a 2 out to reduce the numbers, and that will leave 3c squared plus c minus 4 equals to 0. We can now trinomial factor what's left, and that'll give 2 times, since it's 3c squared, it will need to be 3c and c. And we need two numbers that multiply to be a negative 4 and add to be a positive 1 when one of them is multiplied by a 3. 4 can be a 4 and a 1, or a 2 and a 2. And it seems like maybe the 4 and the 1 might work if the 4 is put here and the 1 is put here to make the 4c and the 3c. And that can add to be a positive 1 if the 4c is positive and the 3c is negative. So we'll want a positive 4c and a minus 1 to make a negative 3c. Since this is equal to 0, we can have 3c plus 4 equal to 0, or c minus 1 equal to 0. 3c plus 4, we can subtract 4 from both sides, so 3c equals to negative 4, divide both sides by 3, and c will equal to negative 4/3. And then c minus 1, we can add 1 to both sides, so c equals 1. We want to determine whether these are in the interval. We have to be between negative 2 and 2. Negative 4/3, the first one we have here, is something that is more negative than negative 1, because negative 3/3 is negative 1, but it's not as much as negative 2, because that'll be negative 6/3. So it's not lower than negative 2, so it's in the interval, so we will keep the negative 4/3. C equals 1 is not bigger than 2, and it's definitely bigger than negative 2, so it's also in the interval, so we will keep it as well. So we have two values this time. We're guaranteed at least 1. We can have more than 1. We have 2. And there's the two numbers, negative 4/3 and 1, that satisfy the conclusion of the mean value theorem.